Okay, in this video we're going to be talking about the rules of exponents. And so what you're looking at right now is really pretty much everything that you need to know regarding the rules of exponents at this point in time. Now, all the questions that are going to be dealing with will always fall back to these situations right here. Okay, these rules. And so do not forget about them. Know what's these rules are talking about because we're always going to fall back to them. So let's try a couple. And this is on the worksheet that we dealt with earlier this week. So let's go ahead and get started. This first one, letter A, is dealing with 5x squared times 14x to the third power. And so what we're going to do is a simple just multiplication. We're going to take 5 and multiply it by 14, and when we do that, we get 70. And the next thing we need to do is multiply x squared times x to the third power. Now, if you notice, going all the way back up, this is the rule that we need to apply. Notice whenever you have an x to the third power multiplied by another x to the second power, you're taking the two powers and you're just adding them. So when you multiply the square and the cube, you get x to the fifth power. All right. Now let's look at B. Now we're going to do a couple simple ones real quick, and then we're going to move into some more challenging ones. All right, so this one right here, you have 12x to the fourth power, y to the ninth. Now what you're doing is you're going to be doing this rule right here. Okay, so hopefully you're looking at that as we're going through that on your worksheet. So what I would do, and this is what the worksheet did, was they expanded everything. So when you say x to the seventh power, they wrote 7x's. And the reason I'm going to do that is just because of the fact that it's visually easier to see. So let me do that real quick. Okay, there you go. And so very simply, if you notice back up here, whenever something is the same as it is on the bottom, we're just going to cancel out. So we are going to cancel, let's see, 1, 2, 3, 4 on the top, 1, 2, 3, 4 on the bottom. We're left with 1x on the bottom. And then let's see, 1, 2, 3, 4, 5, 6, 7. All right, so 1, 2, 3, 4, 5, 6, 7 y's. 1, 2, 3, 4, 5, 6, 7 y's on the top get canceled out. So what we're left with is, well, we got to deal with the number here. 12, 3, let's see, 12 over 3, that's division, so that's 4. So that'll be 4, but notice that we have 2 y's left on top, so the answer is going to be 4y squared over, there's an x left, which is x. And there's your answer. All right, let's try this last one before we move into something a little more challenging. This problem right here, we are raising everything in this parenthesis to the power of 2, or we're squaring everything. So if you look up to our rules here, this is what we're doing. Okay, where we're raising everything to the another power. So what I'm going to do is I'm going to distribute this 2, and I'm going to multiply it to the y squared to the x to the third power. And see, this 3 here, a lot of students don't realize this. This 3 actually has an unseen 1 here, which means you're going to take this 2 and you're going to multiply it by that unseen exponent of 1. So when I do that, I get 3 squared x to the sixth power, because remember, you're multiplying y to the fourth power. Well, the last thing you need to figure out is the 3 squared, so my final answer will be 9x to the sixth power, y to the fourth power. All right? Now, let's move on to problem F, which is right here. All right, so problem F, what we have now is we have negative exponents. Okay, now whenever you have a negative exponent, let me write this right here. A negative exponent, maybe that should be exp, that might be a little easier. What I want you to do is flip it. That's what you need to remember. You're always going to flip a negative exponent. Now the question is, where do you flip it to? Well, pretty simply, do you see how this a to the negative 3, see how this is the numerator of the fraction? So when we flip it, what we're going to do is we're going to put it down to our denominator. All right, so let me just do that right now. I'm going to go ahead and cancel this out, and I'm going to bring this down, a to the third power. But one thing I want you to notice is that we already had a squared. So since there was already an a squared down here, and we are multiplying again by a to the third power, that tells me that the a exponent will be changed. So my numerator, notice I rewrote it without the a, 16 a to the fifth power, b to the fourth power, and then c squared. Now everything has been flipped the way it should be. So now this brings you back up to a problem just like problem letter B, and so you should be good to go. And we're not going to go any further with that. And so if you have any questions with this particular problem, let me know when you get to, or when you see me again. Okay, we're going to pick up to something a little more challenging, and that is letter M. Now notice what letter M is. It's a fraction, but it's being raised to a power of -2. Now, don't get confused here, because this basically is nothing more than, I'm going to circle it again, it's this rule again. That's the rule that we're dealing with. So what we're going to do is we are now going to distribute this -2 to every single exponent that is written inside this parenthesis. Now the thing to pay attention to is, remember, this this M here, not M, this 4, I'll get it right. This 4 has an unseen exponent of 1, and this 6 has an unseen exponent of 1 as well. So what I'm going to do, once again, is I'm taking this -2 and I'm going to distribute it to every single exponent in this fraction here. So when I do that, it becomes 4 -2 m -8 n +6 p -4 over 6 -2 m -4, and then lastly it will become n -4. All right, now we've already distributed everything, but if you notice, we have negative exponents. So whenever we have negative exponents, once again, going back to what we did a minute ago, you have to flip, because remember, negative exponents equals a flip. So that's what we're going to do. We're going to take everything that has a negative exponent and we are going to change it, or relocate it, so to speak. And so let's start at the top. Notice that this 4 -2, it's a negative, so it's going to go down. So it'll become now 4 +2. And remember, whenever you flip it, the negative kind of drops off. This m -8, we're going to bring this down, m to the 8th power. See this n to the 6th power? It stays. So I'm just going to write it right up here, n to the 6th power. Because it's not negative, it stays. And then you have b to the 4th power. Okay? Now let's do the denominator. We're going to have 6 -2. We're going to bring that up to where it would be 6 squared. This m -4, we're moving that up. Now it's going to be m to the 4th power. And this n -4, we're bringing that up too, and now that'll be n positive n to the 4th power. But one thing I want you to pay attention to is that we already have two n's up there. We have n to the 6th power, n to the 4th power. So what I'm going to do is I'm going to combine this 4 exponent and this 6 exponent. So now I'm left with n to the 10th power, and I'm going to get rid of this. So from here, you're able to figure it out, because it goes back to this type of problem right there, where you're just going to expand and then cancel out everything that's the same, and then simplify. Okay, this next one that we're dealing with is going to be dealing with radicals. All right, and this was on the back page of your worksheet. We're going to do letter A here. Notice what we have here. We have a 5. And what that means is taking the 5th root. That's the root that we want to take. All right, taking the 5th root. And basically what that means in simple form, what number can you multiply on itself 5 times over in order to get 243? Well, in your calculator, and if you notice, there's a little tutorial here. It tells you exactly what you're going to do. Is in your calculator, you're going to take 5, and then you're going to use this button, this key right here, and then you're going to type in 243 and hit enter. And your answer is going to be 3. Okay? But the thing I want to pay attention to, and I'm going to scratch this out for a second. is that we can actually rewrite this in in an exponent to where it might be a little easier for you guys to see. And so what we're going to do is we're going to rewrite this. We're going to convert a problem that looks like A to a problem that looks like C. Okay? And here's how you're going to do it. The first thing you got to pay attention to is the fact that you have 243. Now remember, there's an unknown 1 as an exponent. Okay? So what I'm going to do is I'm converting this A, remember, I'm converting this problem right here to a problem that looks like this. So if you notice, what's the difference between the two is the fact that this one here has a radical to where this one doesn't. And the way that you do this is very simply, you remove the radical, and then you're going to take this 5 and you're going to write it as a denominator to the exponent. Okay, so actually, once we do that, I'm going to write this over here because I just ran out of room. It's going to be 243 to the 1/5 power. And you're done. So technically what you could do in your calculator is you could have taken, and I'm going to write right here because I once again ran out of room, 243, and if you raised it to the power of 1/5, and that's my little caret symbol that's you're going to use on your calculator, you're going to get the same exact answer, which is a 3. All right, so in a review, and I'm going to write right here because once again, ran out of room. If I was given a problem where, I don't know, I'm going to use a variable this time. If I wanted to find the 4th root of x to the 3rd power, well, if I wanted to write that as a fraction or as an exponent that is a fraction, I would simply remove the radical, get that out of here, and then take the number that is outside of the radical and make it the denominator for my exponent here. So that means my answer will be x to the 3/4 power. Okay? And there's going to be more to follow. We just have kind of ran out of time. So I'm going to add to this video a little later. But thank you very much for watching.